A manufacturer claims that the mean weight of their chocolate bars is 200 grams with a standard deviation of 5 grams. A customer randomly selects 20 chocolate bars, measures their weights, and calculates the sample mean as 194 grams. Calculate the standard error of the mean for samples of size 20. So size 20, that is our n. So we've got sigma over root n is equal to 5 over root 20, which is 1.1180, correct to 4 decimal places. Determine how many standard deviations away from the population mean this sample mean lies. Now we could do that if we like via a z-score. So our z-score would be our value, take away the population mean that we were given up here, divided by the standard deviation. And of course that means the sample standard deviation or standard error. And that would give us, if we calculate that, negative 5.37. And that means that it's 5.37 standard deviations from the mean. Is this result unusual at the 5% level? Justify your answer. Now, at the 5% level, just to explain that again. So if this is our standard normal, remember that Z is N01. You've done that in your methods course. And if we have 95% in there, meaning 5% at the ends, 2.5% at each end, which is what this 5% is referring to. And if you do an inv norm on that, you'll find that the value is about 1.96. Let's just have a quick look at that on the calculator. So the way I usually like to do these is again in the e-activities here. We've got a z-score for confidence level. And if we do a 0.95 here, solve for Z, and there you go, there's your 1.9599, so that's your 1.96 just there. So we can see that 5.37 would be over here. So 5.37 is greater than 1.96, so this is unusual at the 5% level. And indeed, probably a much lower level than that. So a 1% level would be out here somewhere. But certainly at the 5% level. And in the case of manufacturing like this, you would probably want to check your machine settings to see if that is just randomly a very, very unlikely sample, or whether something's gone wrong with your production.